All right, everybody, Mr. Carlson here, and we're going to take a look at a different type of stoichiometry problem here using our gas laws. So this one's a little longer, a little more complicated than the ones from the other day. So if we read this problem, what we have here, it says a sample of methane gas which has a volume of 2.8 liters at 25 degrees Celsius and a pressure of 1.65 atmospheres. If we mix that with a sample of oxygen gas that has a volume of 35 liters, it's at a temperature of 31 degrees Celsius and has a pressure of 1.25 atmospheres. The mixture, this mixture of methane gas and oxygen gas, is ignited to form carbon dioxide and water. So these are our products, carbon dioxide and water. Calculate the volume of CO2 formed at a pressure of 2.5 atmospheres and a temperature of 125 degrees Celsius. So there's kind of quite a bit of information that they give us. Let's try and break this down, shall we? So let's first write out what the reaction is. We've got methane gas here. Methane gas, and it's reacting with oxygen gas. So those are our reactants. So let's write that out. Methane gas, in case you didn't know, is CH4. CH4 is the formula for methane gas. We're combining this with oxygen. Remember that oxygen is diatomic, so you're not going to want to put just O by itself. You're going to put O2. So we've got methane gas combining with oxygen gas here to give us, they tell us the products are carbon dioxide and water. So I'm going to put CO2 and water, H2O. So here's our reaction. And before I go any further, let's make sure that this is balanced as well. So let's see, I've got one carbon on the left, one on the right. I've got 4 hydrogens on the left and only 2 on the right. So I'm going to put a 2 here to balance out my hydrogens. And then I've got 2 oxygens on the left. I've got 1, 2, 3, 4. So I'm going to put a 2 here to balance out that, and we are good to go now that this is balanced. Okay, so I've got my balanced reaction. Now, what's the question actually asking us to figure? What's our end goal here? Our end goal is to calculate the volume of CO2 that's formed at this pressure and temperature. So we're trying to figure out a volume of CO2 gas. So I want to know the volume that is formed from the CO2 gas. So again, this is, very typical of a lot of the problems that we saw in previous units of stoichiometry. We can figure out how much of this that we make if we know any of the other amounts. So if I know the amount of O2 gas that I have, then I can convert it into how much CO2, or if I know how much methane. But here's the thing. In this problem, they don't tell us any amounts except for they tell us the volumes of each of those starting gases. They tell us the temperatures of each of these starting gases, and they tell us the pressures of each of those gases. So I'm going to write down those underneath each one. So for CH4 here, they tell us that that methane gas at the beginning, before the reaction occurs, it has a volume of 2.80 liters, so 2.80 liters. It has a temperature of 25 degrees Celsius, temperature of 25 degrees C, and it has a pressure of 1.65. Pressure 1.65 atmospheres. And same thing for O2. They give us those parameters as well. They give us a volume. They tell us that the volume of the oxygen gas is 35 liters, 35.0 liters. They tell us the temperature is 31 degrees. Temperature 31 degrees C, and a pressure of 1.25. 1.25 atmospheres. they also tell us what the pressure and temperature of our CO2 gas is going to be, because they tell us that the volume of CO2 formed at a pressure of 2.5 atmospheres. So I know that this gas is going to be, once it's formed from this reaction, is going to have a pressure of 2.5 atmospheres. And it's going to have a temperature of 125 degrees Celsius. Okay, that is everything that the problem gives us. That is all the information that it gives us. And so we have to figure out somehow what is the volume that is formed from this reaction. Well, let's think about this. We know that, let's just write over here, we know that we're working with gases, and we have this ideal gas law. Pressure times volume is equal to the number of moles times our gas constant times the temperature. So PV is equal to nRT. Well, I'm looking for volume here. I want to know the volume of CO2 gas that's created. So if I rearrange this to solve for volume, I'm going to get nRT over pressure. Well, let's take a look. I know the pressure of the CO2 gas, so I have this part of the equation. I know the temperature, 125 degrees C, so I can plug that in for T. R is just a constant, always the same number, but I don't know N. I don't know the amount of moles of CO2 that I have formed. So I have to figure out first how many moles of CO2. If I can figure that out, if I can figure out how many moles of CO2 are produced, well, then I can just plug this into my equation here to figure out the volume that's formed then, since I know the pressure and temperature as well. So my first step is to figure out, how do I know how many moles of CO2 gas that I have? Well, that is going to come back to these over here. So what I need to figure out is how much of either one of these that I have, and then I can, once I know how many moles of either O2 or CH4 that I have, then I can just use the molar ratio from this reaction to convert into how many moles of CO2. But if I look over here, I don't know how many moles of CH4 or O2 that I have. So I need to know the N of these ones. Well, for these ones, I can actually figure that out because, again, let's come back over here. I can rearrange this equation to solve for N, can't I? If I do that, so N, to get N by itself, I'm going to have PV over RT, which I have everything that I need. I can figure out how many moles of O2 and how many moles of CH4 that I have because I know the pressure, I know the volume, and I know the temperature of those two gases. So let's do that first. Let's figure out how many moles of each of these that I have doing that. So using this equation here, so the number of moles of, we'll do CH4 first, is equal to pressure times volume, so 1.65 times 2.8 liters, 2.8 over R, which is our gas constant, so 0.08206 times the temperature, 25 degrees Celsius. Now, remember, we need to put that into Kelvin, so we're going to add 273 to that. So 273 plus 25, it's going to give us 298 Kelvin. Crunch the numbers on that. And let's see, what does that give us? That gives us 0.189 moles of CH4. So that's my N for CH4, 0.189 moles. That's how much CH4 I'm starting with. Let's do the same thing for oxygen. So number of moles of O2. Same setup, just different numbers that I'm working with. So the pressure for my oxygen is 1.25 atmospheres times the volume, 35 liters, over our constant, 0.08206 times our temperature, 31 degrees, plus 273, which would give us 304. Crunch the numbers on this, and we should get 1.75 moles of O2. So I'm going to write that up here. So that's how many moles of O2 we have, 1.75 moles of O2. All right, so now that we've figured that out, now how do I use this to figure out how many moles of, because remember I want to get N for over here as well, how do I figure out how many moles of CO2 that I have using this? Well, we're just going to use our molar ratio, right? So I know that for every 1 mole of CH4 that I use, I'm going to create 1 mole of CO2 gas. But I also know that for every 2 moles of O2, I'm going to create 1 mole of CO2. So which one do I use? Do I use moles of O2 and convert this into moles of CO2? Or do I use moles of CH4 and then convert that into moles of CO2? And this hopefully is ringing a bell here. This is where we have to determine the limiting reactant, right? Limiting reactant. We got to remember that. We have to figure out, is it going to be the CH4 that's going to run out first, or is it going to be the O2 that runs out first? Because whichever one runs out first, that's the one I have to use to convert into CO2. Okay, so we have to figure out the limiting reactant first. Now remember, there's a couple different ways to do that. Let's figure out doing it like this. What we're going to do is we're going to say, okay, I'm just going to pick CH4 here. I'm going to say, okay, if I have 0.189 moles of CH4, what I'm going to do is I'm going to say, okay, I know that based on this equation up here, I need 2 moles of O2 for every 1 mole of CH4. Now if I do the math on this, right, 0.189 moles of CH4, so 0.189 times 2, that gives me 0.378 moles of O2. And what that's saying is that if I use, hypothetically, if I use 0.189 moles of CH4, that means I'm going to need 0.378 moles of O2. Well, if that's how much I will need, if that's how much oxygen I'm going to need, hypothetically, if I use this much CH4, well, let's compare that to how much I actually have. I actually have 1.75 moles of O2. That means I have way more than enough O2. In other words, this one is in excess, right? I have more than enough O2. This one's in excess, which means this guy, the CH4, is limiting. He's going to run out first because this is the one that's in excess, okay? So now we've identified our limiting reactant. It's CH4. This guy's in excess. So now I know I'm going to use this guy. I'm going to use this amount here to convert into how many moles of CO2 that I have. So let me make a little more room here. Okay, coming back. So I'm going to use, and really we actually don't have to do any math here because look, this is a 1-to-1 ratio. But we'll write it out anyways just to make sure. But look, I've got a 1-to-1 ratio, molar ratio, meaning for every mole of this I use, I'm going to have 1 mole of this. So if I have 0.189 moles, 0.189 moles of CH4, and I convert that into how many moles of CO2, well, it's a 1-to-1 ratio, so 1 mole of CO2 for every 1 mole of CH4, right? Which means I'm going to have the same amount, 0.189 moles of CO2. Okay, so now I know this. I know that this is 0.189 moles. Okay, and now we're still not done because that's not what the problem is asking. The problem doesn't ask how many moles of CO2. What it asks is, what's the volume? And so now I can use this guy right here to figure that out. because now I know N, I know the temperature, I know the pressure, and now I can figure out what's the volume. So volume of CO2 is equal to N, which is 0.189 times our gas constant, so 0.08206, times the temperature, 125 degrees C plus 273, right, would give us 398, all over our pressure, which is 2.5 atmospheres. Crunch the numbers on this, and we would get 2.47 liters of CO2 gas. So again, that is how much, that is the volume that will be produced, the volume of CO2 gas that will be produced from this reaction of methane and oxygen gas. So hopefully, I know that's kind of a longer problem, it's a lot of steps involved in that, but if you just break it down piece by piece, one thing at a time, taking it step by step, and you should be able to do it. Keeping in mind that if you're looking at the amount of something produced, anytime we have a problem where it says the amount of something produced, typically, more often than not, you're going to have to figure out which of these is limiting and which one is in excess. And when we're working with gases, we can use the ideal gas law here to help us determine the number of moles in each one.